Welcome to Enginerds, where we handle all your assorted engineering questions. Today, we're tackling the concept of momentum. Have you ever wondered why we have speed limits? Have you ever wondered why we have different speed limits on different roads? Well, hold on to those questions for now. Picture this story about a girl named Allie. Her ride is really late to pick her up, and she has no way of getting in touch with them. She doesn't know why they're late, but she has a pretty good guess. Her dad was supposed to pick her up.
I'm late. Hey, Allie, I'm here. Sorry I'm late.
It's okay. Why are you so late? You know it's soccer practice.
I'm sorry.
Can you speed up?
Should he speed up? Well, maybe. Let's see what could happen. So, what's the science behind this? Well, there are a couple of concepts in play here, but like I said earlier, we're going to be focusing on this one, momentum. The equation for momentum is pretty simple. P equals m times v, where P is momentum, m is mass, and v is velocity. Mass is similar to, but not the same as weight. However, on Earth, the difference is less important, so you can still measure it by getting on a scale, so long as you set it to kilograms. Velocity is like speed, but it also requires saying what direction something is going in. Since momentum is mass times velocity, it can be thought of as your moving mass. And I know you've been dying to ask, why is the symbol P? That's because it comes from the old Latin word impetus, the same one push and pull come from. And if they chose M, it would be confused with mass. To bring these back to collisions, let's take a look at these calculations. The average mass for a car is roughly 1,000 kilograms. This shouldn't change while you're driving. Now let's see how momentum changes when you drive at different velocities. In this example, V1 is 60 miles per hour, V2 is 70 miles per hour, and V3 is 80 miles per hour. These values have been converted to metric units. After performing the necessary calculations, we can see that as velocity increases, momentum also increases. Let's see how this looks in real life. Watch as the same model car is crashed into a wall at steadily increasing velocities. As the calculations showed, as velocity increases, momentum also does, and as both of those increase, damage also increases. But what if you had a really big object, but it isn't going very fast? As you can see with the train, it still causes a ton of damage. As you just saw, mass and velocity matter for collisions. And while you can't control your mass, you can control your velocity. Allie probably shouldn't have asked her dad to speed up. Your safety matters, and speed limits are there for a reason. That's all, folks. See you next time when we tackle another engineering concept. Until then, this is Enginerds, signing out.